Hello students, so today we will learn about the third chapter of the NCERT maths textbook for class 6, and the chapter's name is number play. Basically here you will learn about various types of number puzzles. Okay, and today we will be talking about two very interesting puzzles. First is this students standing in a line, and next, quite related, is the concept of supercells. So let us start. Now here, so this is the case 1 or the first puzzle basically. Now here you can see some children in a park who are standing in a line. Okay, now above each student there is a number you can see. Okay, now the question is, what is this number? Let's see. You see, suppose the children rearrange themselves. See over here. So this is the first position. This is your second position. Okay, now see, in each case the numbers are different. See, this fellow, his number was 0, whereas he was standing at the end. He is also standing at the end over here, but the number is 1. So what is this number? What does this signify? Let's see. Basically here you see, a child will say 1 only if there is one taller child next to him. Say for example this child. This fellow is taller than him, that's why he is saying 1. Next, a child says 2 if both the children standing next to them are taller. Say for example this girl. See here, this boy here and this girl here, they are both taller than him. That's why she is saying 2. Same for this small kid over here. Both these boys are taller than her. That's why she is saying number 2. Next, you see, a child says 0 if neither of the children standing next to them is taller. Say for example over here. See, she is saying 0 because this boy is not taller, rather shorter than her. Okay, so that's the logic. So each person says the number of taller neighbors they have. Okay, so now let us start considering these 3 questions. So you will learn about some very interesting concepts if you consider these 3 questions. Let's start with the first one. Okay, now the first question is, can the children arrange themselves so that the children standing at the ends say 2? Okay, so we want the person who is standing at the end to say number 2, something like this, and we have to do the arrangement. What do you think, students? Is it possible? The first question. Next, if it is possible, then let us try to do this. Now let's try to change the number. Say for example over here, suppose we interchange the small girl's position over here, then what will say, you see, this boy over here, he is taller than her, so she will say 1. Okay, next, this fellow also, he will say 1 since he is taller than him. Now you see, in no case the child standing at the end can say 2. Why? Because the person standing there closer beside him or her will be either taller or shorter. So the number will be either 0 or 1. So 2 is not possible. So the answer to this question is not possible. Understood? Next, now suppose I change this question somewhat. Okay, so that was question say 1A. Now this is say question 1B. I am changing this question. Okay, So let me write it. So this was 1A. What was 1A? The 1A was standing at the ends. So this is important. Now in question 1B, what change I am doing is the following. Can the children arrange themselves so that the children standing at the ends, I am rubbing this off. Instead I am writing standing near the ends, near the person at the end. So if I include this, then what do you see? See, again I am doing a change over here, sort of shuffling. So what I am doing is basically, first I am putting this, swapping her position with this small child's position. Next I am doing the swapping over these two positions. Okay, so if I do this swap, I get this position over here. So you see, this girl can indeed say 2 because both these fellows are taller than her. Next, here you can see, again if I put this girl over here and the boy again over here and this fellow I put over here, then both of them are taller than him, so he can also say 2. So if the question is changed like this, for the children standing near the person at the ends, then it is possible, otherwise it is not possible. Actually you see, in this case over here, this girl can also say 2. So we have got a pattern. So what is this girl saying? This girl is saying 0, right? Because nobody is taller than her. Then we have got 2. Then again this fellow will say 0. Then again 2. Then again this fellow will say 0. Then again what? She will say 1. Then again 2 and he will say 0. So this pattern is basically 0, 2, 0, 2, 0, 1, 2, 0. Okay, fine. So the next question, question number 2 is, can we arrange the children in a line so that all would say only 0? That means nobody is taller than him or her. Now let us do an arrangement like this. Let us do some changing. What I have done is, basically I have arranged this in the descending order, or basically you see, he is the tallest guy and she is the shortest. Okay, tallest to shortest. This is what I have done. Now here, what do you think? Since he is the tallest, of course he will say 0. Next, what about him? He will say 1. Then she will again say 1. Then this girl will say 0, since she is at the same height. Again 0, again 1, again what he will say, almost at the same height, so 0, and she will say again 1. Okay, now you see, all of them can only say 0 if they have the same height, right? Other than that, so this is only possible in the case of same height, but here they don't have, so this is not possible actually. See, because if there is one person who is taller, say for example, let me consider that all of them say, let me consider this case, suppose all of the children are of the same height, all of them, this is the height of the children, all of them are of the same height, but one is taller. What will be the number? This person will say 0, this guy again 0, again he will say 1, again he will say 0, then again this one will say 1, again 0 0. So you see, if there is only one person who is taller, then it will affect the nearby person's decision, and as a result a number other than 0 will appear. So in this case, here it is basically not possible. Okay, the next question is, can two children standing next to each other say the same number? Now this we have just done when we have ordered them starting from the highest to the shortest. Okay, the tallest fellow to the shortest fellow. See, here you can see two fellows saying the same number. They are saying the same number 1 again, and these two girls, they are also saying the same number 1. Okay, next we will consider the second case, and there we have to consider 5 children, all of different heights. Previously we have considered, you see over here, 8 children. Now we are considering 5 children. Okay, so the first question is, can they stand such that 4 of them say 1 and the last one says 0? So this is the question. Is it possible? Well, of course it is possible. See, I have just done this. Okay, so what I have done is ascending order from shortest to tallest. I have arranged all the 5 children, and see, this girl, she will say 1. The boy again will say 1 because she is taller than him. Again she will also say 1 because this fellow is taller than her. Again he will say 1 because this fellow is taller than him, and so he will say 0 because no one is taller. So you see, this is what was asked. So this arrangement is possible if the children are they are asked to stand in ascending order. Okay, the next question is, for this group of children, is the sequence 1 1 1 1 1 possible? Now we have just seen that it is possible to write 1 1 1 and 0, but it is not possible to write 1 for this fellow as well, because this is just not possible. You need one other person beside him who will be taller. But then again, since that will be taller, if that person is the one who ends the series, 6th person, then there will be 0. Okay, so it is basically not possible, as you can see. Even in ascending order, only 1 1 1 1 0 is possible, but we cannot write 1 in place of 0. So this is not possible. Right, now on to the next question. Okay, is the sequence 0 1 2 1 0 possible? That is symmetry. See, the number increases slowly, 0 1 2, then 2 1 0. So the question is if it is possible or not. Now see over here, this is where what we get from the arrangement in ascending order. We just did that. Next, if we can do this rearrangement, say for example this fellow goes over here and she goes over here, then you see this is the arrangement. You see, we can get, again she will say 0, he will say 1, again this fellow will say 2. So basically what you have to do, you have to do the arrangement of heights like this. This is what I have done, see. Then only you can get this sequence of 0 1 2 1 0. Okay, fine. Next question. How would you rearrange the 5 children so that the maximum number of children say 2? Now somewhat we have considered this in the case 1. So if this is the last arrangement, 0 1 2 1 0, what I have to do, I have to again see the arrangement what I have done. I am putting this fellow over here, you see, this fellow goes over here, this girl over here, and this girl over here, so that there are two people. So this means I have to do the arrangement like this. So the arrangement is like this. Only then I will get 0, 2, again 0, 2, 0. See the height sequence, 0, 2, only 2 taller, again 0, again 2 taller, and 0. See, so it is possible. So now after this first puzzle, let us consider the second puzzle, second number puzzle, which is your supercells. Now if you observe these cells over here, basically a row of numbers. Okay, how many columns? 1, 2, 3, 4, 5, 6, 7, 8. 8 columns. Single row, again another row, 8 columns. Now here you see, if these are all just cells, you say, then you see a cell is colored if the number in it is larger than its adjacent cells. See, for example, over here, this fellow, this cell has number which is larger than the nearby one, so it is colored. Again the same for this one, it is colored. Whereas this one, see, it is not colored because the neighboring number cell's number is 577. So larger than this cell's number. Again this cell is again not colored because the adjacent cell's number is larger than this one. Okay, see, so 626 is colored as it is larger than 577 and 345, whereas 200 is not colored as it is smaller than 577. Okay, good. So now question time. Okay, so the first question is color or mark the supercells in the table below. Okay, now this is quite easy. Let's see over here. See, it is the higher, larger, this number is much larger than this one, so circle. Again this one is also circled since it is larger. This one is smaller than this one. Again this one is larger, but this number is even larger than this. So, and again this is larger than its other adjacent cell, so this is also colored. Fine. Next question, fill the table below with only 4-digit numbers such that the supercells are exactly the colored cells. Now here I have already done this. I have chosen very basic numbers. Say for example 5346, so a number much larger, then 6666, then a lower number, again a larger number. So it is goes like this: larger number, again lower number, again larger number, again lower number. See, this number is much lower. Next I am going for a larger number and keep going larger. Okay, and then it ends. So this means this one will be the supercell in this sequence over here. So this is how I have made. You can choose other numbers as well. Next is fill the table below. Question number 3. This one, where is it? Yes, this one, such that we get as many supercells as possible. So this was the actual question. As many as possible. Use the numbers between 100 and 1000 without repetition. What I have done is, see the arrangement. This is what my strategy I have already mentioned over here. So my strategy is like this, like this. See, and all the high points are the supercells, the ones where I am circling. Okay, so these are the supercells. Now, so out of the 9 cells, there are 5 supercells, right? Good. Next question, find out how many supercells are possible for different number of cells and see if we get some pattern. What is the method of filling a given table to get the maximum number of supercells? Let's see. So suppose, yeah, this is the number of cells. Say number of cells. So there is no point in starting from 1, so we start from 2, 3, 4, 5, then 6 and then 7 for illustration. We have already seen the scenario for 9 supercell case. Okay, 9 supercells, so there were 5 in 9 supercell. Now so I am starting with this one to see. So let's start. So let me write some number, say 100 or maybe 200 I am writing over here, and then let me write 100 over here, so that this is my supercell, right? So this one is the supercell. So here, so this was number of cells, and here let me write number of supercells. So here it will be 1, not just here, let me write 1. Okay, next, this case, let me continue just what I am doing. So 200, again 100, and this time I am putting 300. So tell me how many supercells? See, 1 and 2. So 2 supercells. Next, over here again we will continue with the same pattern. 200, 100, again 300. Now this time little bit lower, right? Say 150. So again how many supercells? 2 supercells. So 2. Next we will continue this pattern. 200, 100, 300, 150. Now say 400. Okay, so again this time it is 1, 2, 3 supercells. See, I have done the other cases as well. So here we will have again 3 supercells, and in this case for the 7 celled one we have got 4 supercells, right? So the strategy is like this. If the number is even, say 2, so when let's find the even number ones first. So this is where is it? Yes, this is even number, this is even number, this is even number. So in the case of even number, the number was 1, here 2, and here 3. So it is basically the number of supercells is cell number divided by 2 if the number of cells is even. Whereas if the number of cells is odd, fine, say over here this 3 odd number, then here it was 2, again here it was 5, in this case it was 3, here also it was 7, in this case it was 4. So in this case you see the rule is something like this. Say cell number divided by 2 plus half. So let me write it down in a much better way. See, I have written it. So in the case of even cell number, say for example 4, the total number of supercells was 2, and in the case of odd cell number, say 7, the total number of supercells was 7 by 2, which was 3.5 plus 0.5, which is total 4. See, this is what we found. Okay, students, pretty interesting. Okay, so this is the next question. So is it possible, so question is, can you fill a supercell table without repeating numbers such that there are no supercells? Of course it is possible. Let's write in the ascending order. Say 1, 2, 3, 4, 5, 6, 7. So this was a 7 celled. Okay, so this one is not supercell since this one is larger. Again this one is larger, whereas here you see this one is larger than this one. So we will say that this cell is a supercell. This one is a supercell. So the answer to this question is, it is not possible to fill the table without repeating numbers such that there is no supercell. There will always be one at least one supercell. Okay, and the main reason is that there is no repetition. Had there been a repetition, then I will have just written 1 1 1 1 1 and all that, and then you can see that there will be no supercell. If I just write 1 everywhere, then there will be no supercell. But if I have to write numbers without repeating, then if all the numbers are different, there will be one number which will always be the largest among them, and because of that number, one supercell will exist. So this is important, students. So note this. Okay, next question. Will the cell having the largest number in a table always be a supercell? Similarly, can the cell having the smallest number in a table be a supercell? To answer this, let us again see the answer to the first 4 questions. See over here, this case, here you see the largest number was 9345. Again, so it was a supercell, because since the number is large, of course it will be larger comparatively to its nearest 2. Okay, see, like this. So since the number is already larger than its nearest number, so it will be a supercell. Next, the smallest number here is 52. Since it is the smallest, some number will be larger than this. So the thing is that it can never be a supercell, but the number nearest to it can have the possibility of being a supercell. Okay, so this is the answer. Yes, and answer is no. So I have given you an explanation as well. Good. Now, okay, the next question. Fill a table such that the cell having the second largest number is not a supercell. Okay, let's see. So this is what, again let us consider the answer to this third question over here. See this supercell, this cell, and here the largest number, what is the largest number? Well, the largest number is this one, so it was a supercell, and the second largest number is 500. Now we have to do the arrangement such that the second largest number is not a supercell. So what I am going to do, see over here, let me swap these 2 positions. So what I am doing is that for this I have to put the second largest number adjacent to the largest number. That means if I do this swap, then here will be 450 and here will be 500. See, so both of them will not be supercells in this case, or is it? No. 600 is more than 500, 500 is more than 450, is more than 300. So in this case there will be no supercell over here. See over here. So that's the rule. Put the second largest number adjacent to the largest number. Okay, last question. Fill a table such that the cell having the second largest number is not a supercell, but the second smallest number is a supercell. Now I have already done this over here. See, so this is just like the previous case over here. So let me do the swap yet again. So if I put 450 over here and 500 over here, then there is no supercell. So no supercell. Now what is the smallest number in this case? The smallest number is 199, and see, the second smallest number is this number. Okay, so the rule of the game is put the second smallest number at the end, and then the smallest number near it. Okay, so this will automatically make this a supercell. Okay, so that's the idea. So we get this and we get that as well. So this is not a supercell and this is a supercell. See the arrangement. Okay, students.